Hey everybody, it's Eric Tremblay here again. This is MNTCP06 Foundational Chemistry. We're in Mod 2, Week 6. And I'm doing a second example now on solving initial condition, final condition gas problems using the gas law. And this one's interesting. It's going to be dealing in a sports scenario. And this example really is a continuation on the first example. So if you haven't had a chance to look at example 1, please look at example 1 first before you come and do this one. Okay? Thanks very much. Okay, I want to bring you to Wikipedia right now to talk about Deflategate. Deflategate, also sometimes known as Balgazi, is a controversy in the National Football League, stemming from an allegation that the New England Patriots used suspiciously underinflated footballs in the American Football Conference Championship game against the Indianapolis Colts on January 18th, 2015. You'll see right here in this part of the Wikipedia article that it says the official rules of the National Football League require footballs to be inflated to a gauge pressure between 12.5 and 13.5 pounds per square inch. So that basically means that the minimum inflation level for a football is 12.5 psi. Now, if I scroll down for a minute and I take a look at another part of the Wikipedia article, you'll see here that at halftime, league officials inspected the footballs, and it's initially thought that many of the footballs were 2 pounds per square inch below the minimum. So what we're going to do is we're going to use this example to talk about an ideal gas law. So I'm going to compare what we did in the very first video, example number 1, where we calculated the mass of nitrogen inside a football that was properly inflated to the mass of a football that is improperly inflated, such as one that you might have seen in Deflategate. Okay, so let's think about the idea of how much the mass of nitrogen gas might differ from a Deflategate scenario to a sort of regulation scenario. So let's go over the data really quickly. I'm going to call situation number 1 the original NFL regulation scenario, and I'm going to write out all the data. Okay, so here's all the data from the regulation NFL scenario. Now I'm going to write out the data, the similar data for the Deflategate scenario. Okay, I'm going to call it scenario number 2. The pressure is 10.5 psi. It's 2 psi lower than regulation. The temperature is the same. No change. The volume is the same. No change. And of course, the number of moles in a second situation, we don't know. And the mass in the second situation, the mass of the gas, we don't know. Both those values will be lower, of course, right? Because if the pressure is lower inside the ball, then that means they've put less nitrogen gas inside the ball, and both those will be lower. Now, one approach you could do is just do PV equals nRT on all this data right here, on this second situation data, and just match it to the final answer in the first situation. That's one way to do it. However, I'm going to show you a way to simplify the mathematics to make it a little bit easier. Anytime you're in a situation where you have a starting condition and a final condition, or two conditions that you want to compare, and some of the data is the same, then I recommend you try to simplify the mathematics. And one way to do it is just to write out PV equals nRT, okay, like this, situation number 1, and then divide it by situation number 2. R is always the same, naturally. And then think to yourself, cancel out the things that are the same. So R is the same. Temperature is the same. The interior volume of the football is the same. So this, what comes out of this is a much simpler type formula. Okay. And in our case, the unknown is N2, so you can rearrange for N2 by doing a little bit of cross multiplication. Okay, and now you can use this particular formula to get yourself the number of moles of nitrogen gas in the Deflategate situation, and then from that you can do the mass of the gas altogether. So let's give that a try. PSI is going to cancel out on both sides. You're going to be left with moles, which is good. If you put that into your calculator, you'll get something like 0.126 moles.
Okay, are the significant figures good? Yes, they are. We started with 3 over here. We've got 3 over there. Everything's fine. Now, of course, now if you want to go forward and find out the mass of nitrogen, you're going to do the molecular weight of nitrogen, which is 28.014 grams per mole. What's going to fall out of that is a number like 3.5297. Consider your significant figures for a second. By the way, the units is grams. Consider your significant figures for a second. It should be 3 significant digits. So you're going to do a little round up here. 3.53 grams. So that is the right answer for mass of nitrogen in the deflate gate scenario. So now you can see that there's fewer grams of nitrogen, right? Versus the 4.2 grams in the regulation NFL. So you could see that if you weighed these footballs, you could actually tell that there was less nitrogen gas inside each of them. Interesting. So what's the moral of the story? Don't deflate your footballs.